Okay, so we're going to start with a more basic equation. We're going to look at example 1, and it simply says the sine of x equals negative 1/2. Hopefully you're able to tell what x represents here. X represents an angle. Specifically, it's any angle that has a sine equal to negative 1/2. Now, some of you can just go straight into finding x from here. Some of you may prefer the additional step of writing, well, x then would equal the inverse sine of negative 1/2. Either of those is fine. Now, the calculator right now, if you use your calculator, it's only going to give you one particular value of an angle that has a sine equal to negative 1/2. So if I do inverse sine of negative 0.5, I'm going to get negative 30 degrees. True, that is an angle that has a sine equal to negative 1/2, but it's not the only angle. So this will typically be a no calculator problem, one where we're going to use our unit circle instead. So what we're looking for is we're looking for some angle that has a sine of negative 1/2. Remember that sine represents the opposite over the hypotenuse, but on our unit circle, since our hypotenuse is 1, it's really just going to represent y. So we're looking for any place in the unit circle that has a y of negative 1/2. And we can find those pretty quickly here at 11 pi over 6 and at 7 pi over 6. So the solution to this equation is x equals 7 pi over 6 and also x equals 11 pi over 6. Now 11 pi over 6 is the 330 degrees, but also it's that negative 30 degrees that our calculator was giving us in the first place. But these are also not the only places that have a sine equal to negative 1/2. We need to account for the fact that for a coterminal angle, we would also have another angle who has a sine of negative 1/2. For instance, yes, 7 pi over 6 has a sine of negative 1/2, but if I added another 360 degrees, I'm right back where I started, and I have another angle that has a sine equal to negative 1/2. And then if I added another 360 degrees, I'm back there again. And so what we're going to do is we're going to say, in addition to 7 pi over 6, any angle that is 360 degrees past 7 pi over 6, so I'm going to actually add, instead of 360, I'm going to add 2 pi because I'm in radians here, and 2 pi is equal to 360 in radians. And you don't want to just be able to say, well, plus one set of 2 pi's. You could add any number of 2 pi's and be back to a coterminal angle that would still have a sine equal to negative 1/2. So we actually write 2 pi times n being just any integer. Any integer. And so as long as we add a whole 2 pi to 7 pi over 6, we'll end up at another place where we have a sine equal to negative 1/2. So when I ask for the general solution, I want you to include this plus 2 pi n because it indicates not only the angle you've given me, but every coterminal angle that is 360 degrees past the initial angle will also have the sine or the cosine or the tangent that we're looking for. The same case will happen here. We need to put plus 2 pi n to really indicate that we have the general solution. 7 pi over 6 and 11 pi over 6 were very specific solutions. The general solution will need to include this plus 2 pi n.